So we're looking here at our rocket project, and we're going to make an assumption. I just made up these numbers here that we have a rocket with a mass of 50 grams and with the engine in it, and then that the force delivered by the rocket engine was 0.8 newtons over a time period of 2 seconds. And when we do that, what we're really trying to find here in this is ultimately you're supposed to calculate total height that the rocket would travel as it goes through its burn phase, where it's burning and rocketing up. And then once the burn ends on the rocket engine, as it continues up, it's going to coast until it reaches the apex. And ultimately, I want to know that distance. I show it better there. That distance going all the way up like that. Now, the best way to do this is to envision two separate cases. One, when it's accelerating upwards, we call that the burn phase, or dB. And this distance here would be dB. And then during the coast phase, calling that dC, and this distance here would be distance for the coast. And then, of course, at the very end, you would just add those two together to find your total distance or the total height. This is a theoretical. It's forgetting about things like air resistance and whether or not the force is exactly even as the rocket delivers it and all of that. So the first thing you're going to want to do is you already are going to know some of the information over here. I've shown the 5 different things we think about when things are moving, but you're already going to know acceleration here to be negative 9.8. Because in this phase here, that's the only force that's acting on it is gravity, so it's going to be accelerating downwards. It's going to be moving upwards, but accelerating downwards from some unknown velocity that we'll find later, and it's going to be slowing down until it reaches 0. That's the point when you want to find out the total distance, or this displacement right here. So your velocity final on this one is going to be 0. And this is actually all we could think about for now, so we have to kind of drop down to here. And there's a couple of these we know right away. We know that it was a time of 2 seconds. That's the burn time. So we already know time of 2 seconds. And we know velocity initial down here. It's starting from, it's not moving when it first starts. So velocity initial is 0. Now it's when we kind of get to the point where we have to start thinking about what is going on here. What else can we find? And in fact, what we're going to have to figure out is acceleration. And to figure out acceleration, we're going to have to think about what forces are going on, and we need to think about an equation. This equation is Newton's second law. Acceleration equals force net over mass. Okay? And to find this force net, to calculate this acceleration, we're going to have to jump over here and do a free body diagram and figure out what the net force is. So the easiest thing to start with is we do know going in the net force upward, which is the force of the rocket engine, is 0.8. And the force of gravity is something that we can calculate using our equation. Force of gravity equals mass times gravity. Mass times acceleration due to gravity. And so we're going to find the force of gravity is going to equal our mass of the rocket engine. Now we need to put this into kilograms. This is kind of a big deal. That needs to be converted into kilograms here. So 0.05 times negative 9.8. That's acceleration due to gravity. And so in fact, we're going to have force of gravity. We're going to find force of gravity to be 0.49 newtons. Negative, it's going to be downwards. So this is showing downwards, so I'm not going to show the negative. But that would be 0.49. newtons. I probably should show this being newtons as well. Now to find net force, we need to use just the equation, or you can think about it as force net is going to equal the sum of the forces, which is going to basically equal these two added together. And since this is a negative, you're going to end up with 0.8 minus 0.49, and you're going to find that to equal 0.31. So we have a net force. It's going to be newtons. That is the force we have there. And so we'll zoom in a little bit here. We're going to have acceleration to equal that 0.31 divided by our mass in kilograms from before, 0.05, and so we would find our acceleration to equal 6.2 meters per second squared. I'm putting in the SI units because I fed newtons in and kilograms in, so I know this acceleration would be in meters per second squared. That's going to get me down over here. If you remember, we needed another thing in this burn phase to figure out what's going on. My acceleration is going to be 6.2. That's going to get me three things. That's going to enable me to calculate my displacement and also my velocity final. And in fact, the velocity final here, as it's traveling up, is actually going to be your velocity initial. The velocity final from the burn phase is the velocity initial in the coast phase. And that's going to be your third one there. And as you should know by using your equations, once you have three, you can solve for, in this case, you're going to want to know displacement, and you're going to want to know displacement, and you're going to add these two together to solve for your total displacement, which is the ultimate question that you're wanting to know. Thank you. I hope that helps.